Welcome to All About Engineering YouTube channel. So in last two lectures we have seen that introduction of open loop system and closed loop system, right? So now in this lecture we are going to see that block diagram representation and signal flow representation of system. Okay, so actually the different one or two examples in ESC, hardly two. Okay, and in gate definitely one example is will going to hit on this topic, right? So and for understanding purpose or for any conversion of any real-time system in block diagram, this topic is much more important, so please understand carefully, right? So now I will start this topic. So actually there are different rules, like nearly about 12 to 13 rules to convert a block diagram. Okay, so first rule is combining blocks in series. Okay, so as you know that in last lecture I taught you about open loop system. So this is nothing but open loop system which have two plants, G1 and G2. So if you are equating this diagram, then definitely you have to just multiply these two blocks. Okay, right? So here I have multiplied these two blocks, that is nothing but G1 into G2. Actually just I am giving some rough introduction about these rules. Okay, further you can study in depth because I am planning to give see different kinds of example. Okay, and this is a somewhat simple theory. Okay, so second rule is combining block diagrams in parallel. If two block diagram blocks are in a parallel, like G1 and second one is G2, then what you have to do according to signs, here plus minus sign is there, right? Plus and minus sign, so you have to combine. That means this G1 have plus minus sign, right, and this G2 have plus minus sign. So I am combining that one. If it is have negative, okay, so minus G1 minus G2, like that one. So shifting a summing point, okay, in front of your plant transfer function. Okay, now I am shifting this summing point to in front of this G1 plant, like here. Okay, so what I have to do, look carefully, just I will clear this one, right? So what is this? Here x1 is there, right, and this is a x2 which have plus minus. So signal will be x1 plus minus x2, right? This is your input signal. Okay, this is x1 and it is multiplying with G1, right? It is multiplying with G1. So final signal will be x1 into G1 plus or minus x2 into G2. That is what I wrote here. Okay, like so what if I am shifting this plant, I mean this summing point to this side, right? This summing point to this side, then definitely my final output should be equal to this one. So how you are able to get, supposedly I am shifting this x2, means I am keeping x1 as it is, and this G1, this system will remain as it is. So I am shifting x2. So here at this point, just I will mark with another current at this point. Okay, at this point what is your output? X1 into G1. In previous, definitely you have this x1 into G1. So now what you have to add this plus or minus x2 into G2. So if I am neglecting this G2 block, so what is your output here? What is your output? Simply x2, right? Just I will change color, right? So it is just x2. So your output will be plus x2, right? But previously what previously it is like x1 G1 plus x2 G2. But now if you are neglecting this G2, then what it is? X1 G1 plus x2. So G1 term here is missing, right? So definitely that's why. But what I told, that definitely if you are changing, if you are shifting the summing point, definitely output should remain constant. So that's why to get a constant output as the previous, I am going to multiply with G2. So I am including this G2. Hope you understood this logic, right? So this logic remains same, means if you are transferring summing point from this point to this point either, or this point to this point, right, reverse transformation. So that reverse transformation rule is nothing but shifting a summing point element before the block, right, means this one. So output remains same logic will apply over here, right, this. So if you are shifting summing point from left hand side to right hand side of block, then definitely you have to multiply that signal with G2, right, and G1, sorry, this G1, right, G1 only, here G1 it is, okay. So you have to multiply with the G1, and if you are transferring this summing point from right hand side to left hand side, then definitely you have to divide it by that gain, right, 1 by G1. So this is somewhat easier. So now we'll move towards next point, right. So as you know that like a summing point, takeoff point is there. This point we called it as a takeoff point, right, this one. Okay, so what is difference between a summing point and takeoff point, that you have to understood over here. Okay, summing point means you are adding one signal, okay, these words are important. Supposedly x1 is there and you are considering this plus sign over here, and you are taking x2. Okay, so what you are doing, you are adding these two signal x1 into x2. But if I am giving example for takeoff point, in takeoff point means just you are measuring the signal from that point. Okay, this is nothing but a measurement. Okay, this represent measurement takeoff point. So this difference you have to understood, right. So next rule, fifth rule, shifting the takeoff point after a block diagram means like previously we have seen that shifting a summing point towards the right hand side. So now we are shifting a takeoff point. So what you have to go here, what you have to do, the output will be previously means before shifting output will be x, this x is multiplied with the G1 and output will be remain as a x into G1, and you are just measuring this x1. If you are measuring from this point, so what it should be x1. In previously I told that if you are making any changes, then output should be maintained as the previous one. So previously what you are measuring x1 means you are measuring instrument showing it as a x1. So in this means after conversion also it should have to show x1. But if I am putting this probe over here, then what it will show x into G1, right, x into G1. So but what you have to represent over here only x. So what you have to do, you have to multiply with 1 by G1. So this G1 will get cancelled to this one, and will x1 will only remain over here. So that only you are doing over here. Understood the logic? You have to understand the logic, right? So that only you are going to do over here. Means in previously for summing point what you are doing, you are if you are shifting summing point, then you have to multiply with a G1. If you are shifting a takeoff point, then you have to exactly opposite, 1 divided by G1 like this. And if you are shifting in summing point, what you are doing, you are multiplying that signal with 1 by G1. And in takeoff point what you have to do, you have to do exact opposite of this, means you have to multiply with only G1. Okay, this is some thumb rule, okay, right, this. But behind this thumb rule you have to understand the logic whatever I told previously. Okay, if you want to understand, then just recap it and try it. Definitely you will understand it, right. And next rule, transfer function of a closed loop control system. Hope you understood this one. Okay, transfer function of a closed loop control system, right. Actually I explained in a video number 1. Okay, video number 1 in depthly, means I explained that at this point E is there. So E is just at that time I consider B point over R minus B is equal to U of S. Then I change this B into C into H of S, transfer like that. So if you want to understand, you can go through that lecture, right. So over there I explain this point. Okay, and in that I actually explained in video 2, I explained that how to convert open loop system into closed loop system, like that. So next point, block diagram transformation. Okay, so supposedly this is the one closed loop. For example, this is a one closed loop system, right? So now I have to convert this closed loop system. This have h feedback. Okay, so I want to convert this into unity feedback system. Then what I have to do, I have to take out this point, this gain means feedback gain into, and I have to inverse that gain and multiply with input point, so r into h of s. So these are simple point only. Okay, just go through this lecture, definitely you will understand it. So now we'll move towards next rule. Okay, that is interchanging the summing point element, right? Interchanging the summing point element. So what you are doing means, finally I told that in every rule there are totally 11 rules. Okay, so you have to remember one thing for to understand one logic. In previous state, whatever you are getting some output, okay, that only you have to maintain in next step also, means after conversion. That is the main motto. Okay, so it is if you understand this, means if you keep in mind this logic, then definitely you are able to interchange, or you are going to apply some different logic, right? So what your output is like that, x plus or minus y, right, and plus or minus z. Now what you have to do, you have to transfer this z signal to this summing point. We'll call it as a 1 and this as a 2. So you have to transfer this z to first summing point. Now it is at a second summing point. So similar, so what you have to do here, z have plus minus. If in case it is a minus plus, then definitely you have to write here right here minus plus. Okay, right, but in this case it is a plus minus, right? So you have to write plus minus sign over here, and for y also it is a plus minus sign, so you have to write plus minus sign. This is a much more simple one. So now you have to focus, means now you have to somewhat focus more on these critical rules, right? So shifting a takeoff point after the summing point element, actually this is somewhat critical as compared to these 9 rules. Okay, these 9 rules are somewhat straightforward, but this is somewhat critical. So like the whatever I told, that means in previous system the output that you are able to get, that only you have to maintain in second step, means after conversion also. So in this step, what is your, this is takeoff point measurement, that is x and x plus y. So now what you are doing, just shifting the takeoff point after the summing point, means if you are able to recap, one rule is there, means what we are doing, this is a gain plant, okay, gain transfer function g, and this is a summing takeoff point x. Okay, this is the input point x and this is output point y. So in that case, what you are doing, you are transferring this takeoff point. At that time, what you are doing, you are making it as a 1 by g, and you are taking simply output x, right? So here it is, what here it is not a transfer function. Okay, what you are doing, you are transferring, means you are transferring your takeoff point in front of your summing point, right over here. So what you have to do, and the condition is that you have to maintain the same output. Okay, so look, so what you are doing, output should be x plus y, so definitely y should come over here, right? Okay, so it will remain as it is. Okay, and your output should be x, so x plus y should be over here. So now my output, right, it should be what, in previous it is x, so it should be x, right? But if you are considering, means if I am neglecting this, I will represent with another gun. If I am neglecting this, right? Okay, so if it is now it is x plus y, right? But what I told, that your each and every function should maintain its previous state. So what I have to do, if I am able to add this, I will take second. If I am making opposite sign over here for y, then this total content will get cancelled. Okay, means this plus or minus y will get cancelled to minus plus, so remaining will be x only. That only I am doing over here. I am taking opposite sign as respective of this sign, right? Hope you understand. So remaining will be x only. Similar, if you able to understand this rule number 11, then definitely it is somewhat much more or approximately same to 10th rule, right? You are now shifting a takeoff point. Okay, so what you are doing now, it is x plus y. So what you have to add, if you are placing this x over here, so what in this summing point, what you have to do, you have to add same sign, because it should be plus or minus. Okay, so like this is one summing point and this is a plus minus, you are taking same point. So I will conclude this topic. Actually it is somewhat easier, right? So these are exactly opposite like this. Just go once through it. In next video I will explain about a signal flow graph, and then we'll go through some numericals on a block diagram, signal flow graph. I mean, in signal flow graph I will teach you about Mason gain formula, how to apply Mason gain formula over any system, and how to reduce a block diagram, what is a short trick for that one. Just we'll go through it. But to understand that concept, or to understand that numerical, first of all you have to thoroughly go through this 11th rules. Okay, just read it. If you are facing any doubt, then please convey to us. Definitely I will try to clarify that one. Okay, right? So take care and all the best.